In this episode, we're talking about how to deliver event to your Lambda function. It's vague, it's made on purpose. We're going to clarify that. Good morning. It's Friday morning in all good podcast application. It's the AWS Developers Podcast with Tiffany and myself, Seb. Today we are welcoming Rajesh Pandey, your principal software development engineer in the Lambda team, the AWS Lambda team. We're going to talk with you about how we, AWS, can deliver event to a Lambda function. But maybe let's start with the basic. Why do we need, what are the use cases? Why AWS needs to deliver events to a Lambda function? What is the use case we're trying to solve for our customer here?
Yeah, in any modern day application that you build, it's basically connecting one data source to like a compute. So anything like any website that you build or any event-driven application that you think, like if you see like two bold diagrams where like a Lambda function is there, which is processing the events, that is like an SQS as a source where let's say you book an Uber ride, and the message that there is an event that gets generated, that event gets delivered to one of the sources like DynamoDB or SQS or a Kafka, and then like you need to do something with that event, and that event then has to go to a compute, like you need to process that event. So one of the most popular ways to build like these serverless applications is like process that event through Lambda function, and that's where like Lambda's event source processing comes into the picture.
Yeah, before Lambda, it was quite, how to say that, cost incentive to build this type of application because we need to pull the request. I remember when I started at AWS, Lambda did not exist. It was a long time ago. That gives my age, but okay. And customer had to write code running on EC2 instance, and the code was pulling the SQS queue, but there was a price per API call to SQS queue, so it was not cost effective to build this type of application. And Lambda simplified all that a lot. But SQS is only one example. There are many others.
I can tell you, like back in when I joined the AWS, like this was like fresh out of college. Back in 2013, I actually wrote my first SQS poller, which was doing a lot of like event processing in terms of like, so we built a system in retail where like we get like catalog data in form of event. Then I wrote a poller, which was actually literally an SQS poller, where you poll and like deploy an EC2 fleet, you deploy your like SQS client, you process those events, then you like actually apply those changes into like your catalog. And all that I had to do that heavy lifting. It was like a 6 months worth of project where like I have to ensure like bunch of things around like availability, like it's up and running and all that. And all of that now you can do through like a simple config. That 6 months now gets converted into like 6 minutes if you
Yeah,
want to call it that.
Because now it's the service doing that heavy lifting for developer. We as developer don't need to write that logic of polling, retrying, making sure the code is running. If it crashes, we need to restart it. But how does it work behind the scene? Can we open the box a bit? Because to do that at the scale at which AWS operates over, I don't know, millions of Lambda functions, queues, and different event source, what's the infrastructure behind the scene? And how does it come? Okay, no, let's start with one question. I will ask my second question after. What's the infrastructure behind the scene?
So there are servers behind serverless, right? And we do say these things. So like behind the scene, there are like a lot of like heavy lifting that is being done, and then we wrap them behind beautiful abstractions. The abstraction is called event source mapping that customers use, and then they define that like this is their event source. But like let's say pick an example of like SKS queue. This is my SKS queues where like all my messages are like getting like accumulated, and this is my Lambda function. So behind the scene, what we do is like we take that config, and we have like built up like thousands, like maybe thousands, like 100,000 of servers running behind the scene, which take these like configs, do the configuration for you, use the standard SQS client, and then we have built a lot of customizations on it. So we spin up a worker behind the scene. That worker gets attached to like your uh, customizes it to like a specific to like that specific customers. We sandbox it, and then we attach it to like an SKS queue, and then like similarly like we after we polling the message, we pass it on to like a sandbox that where like your Lambda code is running. So that is like a very high level view of like how this is working. And of course, it's like a multi-tenant environment. And
And you, as the AWS Lambda service team that you represent here right now, you take care of making this worker highly available. So if one crash, it will be restarted, and to have many of them, because customer can have dozens of queue with thousands of message or millions of message to pull.
yeah. And whatever like I'm saying, this is being done for like millions of customers. So like millions of customers having millions or like maybe tens of millions of Lambda functions. So like one queue can process the messages and can go to like different destinations. So all this is happening for like we are processing trillions of events per day. Uh, I can give you like a good example of like impact in terms of what we do. Think of uh, like there is like the concept of like a like availability zones, right? Like so how do we make like highly available applications is like there's like one availability zone where a lot of processing is being done. Like when a customer creates a like a processor, they typically don't think of like creating it in like 3 or 5 availability zones or like making it like highly available. So like things are running behind the scene for them, but like behind the scene things are running for them, but behind the scene what we do is like we spin like workers into like all the availability zones. So like one availability zone goes down, the work fails over to like the healthy availability zones, and you don't see that impact. I remember uh like around 2019 or 20 time, around that same time, like there was like an AZ outage that happened, and then we were out for like about like couple of hours, like 2 hours. There was like no processing being done because like the work was in like one specific AZ which was impacted, and that was like there was a big flood or something happened to that data center, and that took it down. Uh, and it was not done at that time. So then like it over the years we build these mechanisms in place where like the failover happens like in like real time, near real time, and the customer, those who are like using these services, they never see that like there is something going on behind the scene. So this is like these are like some very high level things that we provide uh, to our customers who are using these like higher order abstractions.
That's the beauty of AWS when a challenge happens in terms of availability for our customer. We do a deep dive study about what happened and what was the root cause, and we implement a plan to avoid that the same problem can hit us again. Hence the improvement that you just described. I have a question about pricing. Tell me if I'm wrong, but I think this is free for customer. I mean, if I have an SQS queue and a Lambda function and I hook the two together, there is no additional cost for the customer. There is the cost of running the Lambda function and the queue, but not the infrastructure in between. And that's quite, it's not typical from AWS because what you're describing, it's a huge infrastructure that must probably cost us a lot of money as well. And one of the things I learned is that when there is pressure on our infrastructure, there is a cost for customer. But we decide to offer that at no cost to facilitate the usage, the development for Lambda. That's the reason.
Yeah, and that makes it a little bit harder for us to like go about like because it's a problem of like making it it's a value added service. You can call it like it's a value added service to like Lambda, where like customers use Lambda and it brings that business to Lambda. But at the same time, it's like we have that difficult problem to solve is like where we have to keep our costs low and as low as possible so that like we are not like cannibalizing like our own business in terms of
Mhm.
like we giving some info for free. So how do we solve this problem of like multi-tenancy where like we pack as much as possible? So like the density is like really high when I'm talking about workers. I'm talking about like 10 thousands of workers being packed into like a really a small box. And how do we swap them out and in when there is a like one queue? Like you can think of it as like a distribution. It's like always like the bell curve kind of distribution where like there are top hitter like heavy hitters and there are like customers those who have like low messages or like one message in a day. So we try to pack them in such a way that like it's a bin packing problem. We pack like customers with low throughput and customers with high throughput and try to pack them as closely as possible in the sense like they're not impacting each other, but at the same time like our infrastructure cost is low. So we build like bunch of these like uh these like you would call it like tricks and tips into like how do we pad these works? How do we solve their bin packing problem so that we serve this customer like this huge infrastructure and they still can offer it for free while
with
keeping their business
up
uh,
with automatic scalability as well, because the customer workload might vary over time or over the season or the
of course, yes.
so you have to scale that infrastructure as well to follow the patterns of customers' applications.
Yeah. Like you think like a heavy hitter coming to your box suddenly and then spiking your traffic. And again, like there are like different sources, and different sources come with like different traits on their own, right? Like queue is unordered message processing, whereas like in the streams that we process is like ordered. So they come with the different challenges. One is like more spiky, one is more latency sensitive. So like all these like constraints are there when we do pack and like we slice our workload to keep it cost effective.
When I hear you talking about that architecture, it resonates in my head somewhere. Firecracker. Are you so Firecracker, for you that don't know about it? It's the open source micro VM that we are using to host your Lambda function itself. That's the solution that allows us to pack a lot of Lambda function in a multi-tenant physical server. Are you using Firecracker for this worker as well?
So not exactly. A firecracker is on the, like, you can think of it as a like a pipe. So like one end is like where the firecracker is, where we execute customer code, right? Like there are different uh like a constraints that we have on firecracker versus the constraints that we want in here. So we do evaluate these things on the ongoing basis, but at the moment we are not using Firecracker to do the polling work as such, but mostly around like executing the customer code where like a strict security boundaries and like these things are required. But yeah, like the problem, like what like resonates and what like you finding similarity is around like the packing problem, right? Like because like some Lambda customer functions is like a 2 GB and someone is like 120 MB, right? Like so there are different configurations. So how do you pack? Like so there's a placement service in like before Firecracker, which actually places these like Lambda functions into like metal boxes. Similarly, we do have like a placement service. So that similarity is like how do you repack like a customer workload with like a low throughput workload and high throughput workload into like a box. So there's a placement component that is there in both like the Firecracker and before in front of Firecracker and in front of like Lambda workers like Polar workers.
Like as a developer, for me, like this seems like it's seamless for me. Like if I have a Lambda function and I use an SQS queue, this like pulling event is automatically added to my stack. Like I don't even have to think about it, right?
Yeah, that's the beauty, and we want you to not know about it. Like that's the beauty of abstraction that we have built, and like I think we take pride in like building these kind of structure where like you think of it like SQS and Lambda, not anything in between. But yeah, like a lot
That's
of
so
people
cool.
say that like they don't know like how this heavy lifting is being done. Yeah.
Yeah, but so Seb, you said that before that didn't even like that did not even exist. So how did people do before the pooling events? Like you had to add something in between your Lambda function and
Yeah.
your like SQS, or like what how did you do before?
Yeah, at the very beginning of Lambda, that's a very legitimate question. There was no such polling mechanism. So how did customer interface a queue with a Lambda function at the beginning of Lambda 10 years ago?
Like any standard queue polling is like you spin up a box, you deploy an SKS client, and you pull messages, and they do that thing. And so like all that, you can call it like DIY solutions, right? Like where you can spin up a EC2 box, you can deploy an SKS client in there, and then you can pull messages and then batch it and then filter it and like maybe transform it and then do a bunch of things. And then like you like pass it on to like your Lambda function. So you have to do all that work before this.
But that's the thing. Do you still have customers that do that? Do we still have customers that do that? They don't even know about pooling events.
I won't claim, but like it's one of those things where like at one point we break even where like the DIY is costlier than actually using these configs, and it's like 10x to like 100x cheaper, if you will.
Wow.
Uh,
Mhm.
so
Whoa.
like there is like less, but like there are still customers, those who want like some higher order, like very specific things that they want to do with their and like their events, right? Like say before they go to like, so we do provide some higher order features, like you can think of like batching, like batch window in seconds, filtering, and some like some of the features we added are part of like pipes launch, like the transformation and all. But there are some customers, those who may want to do more things before they pass it on to like their RNA function. So they may have like these DIY solutions. But we always look and like talk to our customers if there's anything that you feel that is of like higher value, and that should be built into this abstraction. So we go and build those things.
So what are the event source that we support today? Because from the beginning we say SQS to take one simple example, something that
Yeah.
we can represent in our head, but it's much more than that.
Don't quote me, but I think at around 10, like we always are launching some event sources, and like we try to cater to like a different set of customers, those who are like looking for like increasing, or like we are looking for like increasing Lambda options with like those sort of use cases. So broad categories like around queuing sources and the streaming sources. Uh, Streaming sources, like very popular ones, are almost like all of those like heavy lifters around like Kinesis, like the top customers of Kinesis, and like DynamoDB streams. And the Kafka, we recently launched like bunch of new features into like Kafka with the provision mode. So Kafka, Kinesis, DynamoDB, DocumentDB is another that is supported today. On the streaming side, on the key side, like SQS is there, SQS FIFO is there, ActiveMQ, RabbitMQ. These are coming to my mind, but like I think I'm pretty sure like there are a couple of more.
Yeah, it's difficult to make a list, and as you said, we keep adding new source to the list.
Yeah.
Looks to me that these are two different use cases. The one about event-driven architecture, queue, event bridge, and these type of things. And then the streaming. So can we talk about these two different use cases? Event-driven architecture, something happened. I start an asynchronous process through queue, through event bridge. Yeah, we talked already about that for the last 15 minutes. So what about the other, the streaming? What are the use cases there?
Real-time gamers, like sometimes like you're doing an activity and playing game, and you want your events to be delivered and to whatever you're doing. They are like a very like a big users of like these like streaming workloads, where like a Kinesis is like very much into like real-time like processing.
Log
And there was like a
processing, I
big
guess.
log processing is another example where like they want to like build like real-time analytics on top of like their streams. So that's where like they process these events, do batching and transform, and like sometimes like a filtering uh, is another thing that they do, and then like deliver like only like a set of like maybe like for DynamoDB streams. I can give you an example where they want to only listen to like when the price of an item changes, because in their DynamoDB table they store the price of items, and when there's change, there's an event that gets generated, and they want to see only when like their event goes below certain price or something, right? Like it's an just a makeup example, but like they do have these kind of features where they can actually listen in real time. So more latency sensitive customers are like streaming customers, you could say. uh,
What? So I'm a stream gamer, so that's an interesting question for me. Um, I know for a fact that like the lowest, like the acceptable latency for a gamer would be something like below 20 milliseconds. Like, what is this like lowest latency that we can reach?
So again, a good question. Like we try around like 100 millisecond. That is what like we don't quote it like officially as such, because like uh so maybe we can but like it's like real time as real time as possible, based on like the constraint that are available, because like when an event is produced to like event is consumed, there are some like broker side latency that gets added, right? Like so we are always ready, we are ever ready. And again, that the same packing problem that I was talking about, like we have built these mechanisms where like we always attach a worker to a stream, so that like whenever that event is there, we poll it and we get it, and we deliver it to function. Lambda is also very fast, but again, like you can hit an edge case where you You poll, you didn't get so you do like a long polling, you get a message, and then you hit a cold start of Lambda, like maybe ranging from like 100 millisecond to like a 1 second. We are a system which guarantees at least once delivery. So if you shouldn't be losing data at all. What it could be is like you get to see that same frame again. That could happen. You shouldn't be losing any data as such. Uh, and like these like streaming systems, like again, like maybe there are different use cases and there are different systems built on top of these like primitives, right? uh, so there are like I don't fully know like which at what layer these problems gets manifested. So but like underlying primitive is like you have a stream, it's like a log stream, append only log. If you want to define a stream, what a stream is, it's an append only log, and you have iterators onto it, and you attach an iterator to a point, and then from there onwards you just go forward. And if you want to read the messages backwards, then you can create another iterator and attach it to another point, and then you iterate it from there. So there is no loss of message per se, but it could happen that like you see that same message again and again. So there are different layers of like these, like when you build these higher order like applications, there are different layers where like these things can manifest.
And so it's the responsibility of the developer to keep track of which message they receive already and to not process a message a second time. It has to be developed on the customer side.
So currently, that's the recommendation that we have is like we guarantee that we'll not lose the message. We'll deliver them like real time. But if it happens, like you need to like take care of the idempotency today. But that's the promise that we have today.
Amongst all the service that you mentioned, there is one big absent, and it's a very naive question from my side. But what about S3?
Good question. There are distinctions in like how we talk about like event source mapping and then like Lambda async triggers. So Lambda can be triggered asynchronously, where like an event gets generated and then gets pushed to like Lambda stack. So S3 events, when they generate an event, it actually hits like Lambda front end, Lambda load balancer, and then like we have a separate stack to process these asynchronous events. So S3 API gateway, all those like diagrams that you see like where an API gateway integrates with Lambda. So that is being done through like like a different integration point, like an events actually. So they go and hit into like our load balancer. They go into like a separate set of like processing works. So that is like asynchronous processing. I know like this is slightly confusing, and we run into this. So async event processing and event source polling, if you want to characterize them into like these two different buckets. So S3 falls into like async event processing. And we do, yeah, I do work with that system as well.
Yeah, for API gateway and S3, it's the service itself
S3,
directly calling.
SNS.
They are directly calling the Lambda function. We don't need to pull event from S3 or from
yeah. So
API
push versus pull. You want to call it like event bridge.
Yeah.
Is like yeah. So push versus pull. So push is like where like a Lambda async invocation happens, and this like when they're like data at rest. You want to call it maybe data in motion, where like events are there and like an event source. We go and poll those things. So these are like two broad categories through which you can invoke Lambda asynchronously.
But from the developer perspective, this is totally transparent. I write my Lambda function.
This is totally transparent. Yeah.
I receive an event in my handle function. Whoever is calling this this
they don't have to
function,
like
I don't have to think about it.
Yeah, like you go to an SNS console and say that, okay, invoke this Lambda function, and then we take care of everything. Or you go to an SQS and say that I can invoke this Lambda function, and we take care of everything behind the scene. So that's the magic of this thing is like.
Yeah, that's the beauty of it. The programming model is exactly the same for the developer. It doesn't change anything. The Lambda function is invoked and you do your work. It's been a couple of times you mentioned more advanced function, piping, filtering, batching. Can we dive a bit deeper and see what are the more advanced integration patterns that you offer?
We do provide features like a batching filter where like you can actually wait for some time, like let's say like in seconds, you can specify like, okay, wait for 5 minutes before delivering my events to Lambda function. So if you have an event into your event source and then you want to trigger Lambda function, you can do it instantly. You can set your set your batch size is like the number of events that you want to deliver to Lambda function to like 1, and then the moment event is there, we invoke your Lambda function. But sometimes some customers have different use cases where they don't care about like having or receiving the messages in real time. They can set their batch size to like some higher number. They can batch like, okay, maybe batch 10 messages in one go, and then like deliver it. So that like that reduces the cost to like customers, like the number of times you invoke your Lambda function or number of times you execute your functions reduces, right? Like, so there are some customers like that. Uh,
And
then there are like,
I interrupt you before going to the next
yeah,
one, and it means that you keep all the message inside like a buffer to guarantee
yeah,
the
yeah,
delivery of all the message. Because during that
yeah.
time, the message is not in the queue anymore, if we talk about queue, but they are not yet in Lambda. So it has to be stored on your side.
So that's another interesting aspect where like we build this like you can call it like like an in memory buffer, which is like a short term memory. So in short term memory, it's like again bounded, of course, where we pull messages to into like our in memory, and then like we deal with like lambdas like nuances on behalf of our customers. So
And I have another
that
question about batching. You mentioned batching by number of message, but there is a time, a maximum time as well, because if you batch for 10 message and then there is no more message after the 8, the batch will never be delivered. So is there either
yeah,
time
yeah.
or the number of message?
Yeah, so there are two configurations for batching. One is like number batch size. So you can say that, okay, batch size, and then like also a time bound that you can specify. Like try for like 5 minutes and then deliver it. If it doesn't happen, then like even then like deliver it to like my Lambda function, because I want to continue processing, right? Like I want to not halt on like, okay, you said 10, but I get 8. It's like okay, just try for 5 minutes and then go and deliver whatever you have. So we do have these two configurations in there. Yeah.
That's all for me with questions about batching, but you were about to mention other use cases.
Yeah, I was just saying that like there are like the filtering is another really popular use case. Almost uh like for the streaming world, like there is like an event and like an activity is happening, and they want to like just listen to like a specific set of things. So it's a very popular use case, and I think it has like grown rapidly, even beyond our expectations. And we didn't even know like this is like this popular.
What
And
what type of filtering is possible? What type of expression? Is it regular expression? Like is it
yeah,
what is it?
it's like a JSON expression, and I know there's like open source library that like Amazon open source like a ruler
Yeah,
library which we
JMS.
use in like EventBridge. Yeah, yeah, like in EventBridge also, like for defining the rules. Same library we use to keep it like low cognitive load on our customers. But you can use that to like define, and there are like bunch of things that has happened. Like I can talk about like one of the use case where uh, one service built uh, getting their bad host from the fleet of like 10,000 workers based on like this event that getting generated. So once the event gets generated, they specify like, oh, this is my CPU, this is memory, and like bunch of these things. And then they wrote some filters based on like these events to say that, okay, this is most likely like they would do write like bunch of like applications in terms of, okay, this if this combination is there are a bunch of heuristics that you could write and said, okay, this is most likely going to be a bad host, and then you can go and proactively replace that host. So these kind of use cases that I don't think like we were thinking, but like customers are like so innovative in terms of like they come up with like these real powerful use cases where like they use these underlying primitives and build these like top order like use cases on top of that, like these applications and things.
What happens to messages that do not match the filter? In
So
thinking about queues, they stay in the queue? No.
yeah, good question. Like there are things that happen. So like we recently what we did is when we launched filtering, we didn't specify like how many messages were filtered. Only we were like giving you the metrics. So we built an observability feature last year in reinvent where like you can now see how many messages were like filtered, match the filter, didn't match the filter, how many went into like DLQs. DLQ is another thing, is like where if something bad goes, like if your function execution fails, you don't want to like stuck into that message.
Mhm.
You move that message into
To a queue.
like a queue,
The
or like your defined destination. You can call it like DLQ, could be an SNS, S3, or anything.
yeah.
Um, and and then you move on. So like these kind of things are there.
And then pipes. You mentioned pipes. What is a pipe?
Yeah. It is another reinvent launch that we did in 2022. So pipes is like, so what we did for Lambda, we wanted to do it for all of the AWS. It is very popular in like all our customers meetings. They wanted to say that, okay, I actually also want to deliver my event to like X. And X could be anything like a Fargate or like an ECS box or like an HTTP endpoint, or like I want to pull message from SQS, do something with it, and then write to back to again SQS. So all I have to do a lot of things is like I have to write that Lambda function to process, and then again I have to deal with an SQS client to like write it back to that. What if SQS fails? Should my Lambda function fail? Should it retry? And all those things that are happening. So we said, oh, we know how to deal with these things. So we built another abstraction, and again it's a very easy to use abstraction where you can specify, okay, source is an SKSQ and then destination is an Kinesis. I'm just making it up. So you can write SKSQ as source and Kinesis as your destination, and we do everything in between. You don't have to do anything. You don't have to worry about like knowing about like how to deal with like Kinesis or how to deal with SQS or Dynamo, for example. It's just like super easy to use abstraction.
I'm thinking how different it is from using EventBridge, for example, that can also receive events from different source and post them and filter them to other sync or destinations.
So it's event-bridge pipes, and again the difference is like push versus pull, right? Like message sitting in SKSQ, you have to like get that message somehow into your system and then write it to like another SKSQ or DynamoDB wherever you want to be. An event-bridge standard use case is like you push events to an endpoint, and once it's into our system, then you can deliver it to any destination. So pipes is an extension for like pull use cases you can think of. And yeah, and I can tell you that like one I think we have mentioned it's like it's built on top of like Lambda ESMs. So we whatever we build like in Lambda event source mapping, we wrapped it in such a way that like now it can be extended to like an AWS service. So it's a good reusability principle that we used there.
So if I summarize, or if I rephrase just to be sure I understood correctly, with pipes we can connect an event source with an event destination without having anything that I have to write and I have to maintain and I have to deploy by myself. So it's like, as you mentioned, SQS from SQS to DynamoDB, or from DynamoDB stream to Kinesis stream, for example.
Yeah.
But then it's not for free, is it?
It's not for free. Yes, that's the yes, yeah.
So there is a price attached to this type of pipes that customer are deploying.
Yeah. Our idea is like we do provide a lot of like value to our customers, and there are like a lot of more features that we support, right? Like again, at some point, like we have to make sure that like it's financially sustainable, and it makes sense. So we decided to take that decision on like making it like but again it's like very very cheap, and it follows completely service pricing model.
Mm-hmm.
So right before you said, as a developer, there's nothing that I need to do more as a developer in my code. But do I need to specify anything in, for example, my CloudFormation template if I want to deploy everything? Like, is there something specific I need to do, or that I should know?
So you can think of pipes or event source mapping as a primitive, basic primitive, like where like things are doing like connecting from point A to point B. But like these are all part of like an application or a stack, right? Like so like you would have to still write some sort of like CloudFormation where you specify these things, because these are like, okay, now in my stack at one point, like in my service, these 2 points are connected. So you would need to specify those things. So these are like resources that are available that you would have to specify in CloudFormation. If I understood your question correctly.
Okay. Yeah. Okay.
What are the best practice you would share with developers that are listening to this episode, or what are the common traps that developers fall into when they use these type of integrations?
A bunch of times it's like customers understanding like these because you don't understand like this thing where there's something sitting in between. So you come up with like assumptions around like okay, whatever I do in my Lambda function or set my concurrency to like 10,000 and instantly there are messages, I'll get 10,000 concurrency. And people or customers generally forget like there is something in between that does, and that something in between is controlled through a configuration. So customers forget to like tune both these things together in such a way that okay, if you set your concurrency to be like a higher number, you need to also change something in here. Like we recently launched a feature around like max concurrency. Customers were talking about uh like they don't want to exhaust all their concurrency limits in a Lambda function because there are multiple points which
Mhm.
are interacting with a Lambda function. But like your ESM, because now it's a backlog of like 1 billion messages, you instantly exhaust all my capacity. So how can I cap so that only a set of that, like a percentage of that Lambda function concurrency is being used, right? So there is a feature that you could use like a max concurrency that you can set to say, okay, only 10% of my concurrency is what you should use and let the rest 90% being used by others.
With our
Good.
system, we operate against at such a scale that it's easy to flood another system, a customer system. In that case, the Lambda system, which is bound
Yeah.
by the concurrency limit. Okay, so that's something to
Yeah.
pay attention. You said there is max concurrency, and that's one of the parameter customer can use. And there is all the CloudWatch metrics about concurrent function
Yeah.
execution that customer can monitor, put alarms on to be informed when they approach the threshold.
There are like things like some like advanced users, we build features like parallelization factor where some customer you can actually because like you think of like streams are divided into like partitions and shards, and every shard is ordered. So because it's ordered, only you can do is like one message and then invoke one Lambda function, and once it's done then you can move your pointer checkpoint to like advance to like the next one. So some of the time some customers want to like even process a shard faster or like a partition faster. So we build like a parallelization factor where you can actually process a shard faster than like the defined like one by one. So you can process like 10 messages in parallel. And again, it's very specific to use case. Bisect batch where like let's say you deliver a batch of 10 messages together to like Lambda function, and then like one of them is like bad. So how do you identify which message is actually bad? So you can specify that thing. We move that into DLQ. So there's like only a single simple feature that you can enable, and then it does like all that like binary search, uh, like finding like okay, divide that message batch into like two parts, and then like okay, this batch probe this batch, and then probe this batch. Okay, this has problem. Then divide it further. So we do all those things behind the scene for you. All you have to do is like specify like a simple flag. Oh, I want to bisect batch my like my delivery of events. Partial failure is another like so there are a bunch of these things which are there.
So what's the key to success when we adapt this type of architecture as a developer? Is it observability and monitoring? From what you say, I have the impression if I want to succeed, I need to have a good visibility on what's happening on the system and define the proper alarms to be informed when something goes wrong.
Yeah. So as I said, like in reInvent, like we launched setup metrics. Definitely go and enable them. Like you will be able to see like how many events got pulled, how many got delivered, how many are in DLQ, how many filtered. Like this is like another thing is like customers set up these filters, and then sometimes they like one of the common mistakes that I've seen is like customers set up filters and then say like say events that should be delivered are actually getting filtered, and the events that are filtered are getting delivered. So like it's easy to like confuse these things. Uh, so like set up your filters properly, set up your batch sizes properly, and then understand your use case, and then always have a dev environment where you test these things out to make sure that like everything is working. And once it works, I hope you can forget about it. Like there is something like this that sets and it just does its job.
You just mentioned Kafka. That's a recent launch from reInvent last year, 2024, if I'm correct. So the integration with the managed service Kafka, the MFK blah blah. I've always forgot the acronym.
MSK, yeah.
To Lambda.
Yeah, so it's not a recent launch. I would say we launched it in like 2020,
Okay.
and it's like managed streaming service for Kafka, that is like managed Kafka, and then like SMK, that is like self-managed Kafka. So it's really like you have to be an AWS customer to be using this, but you could also be like you can have your own managed you can have your own managed Kafka, like a self-managed Kafka, and you can also still trigger Lambda function. So we build and provide the supports too. What we launched last year in reInvent is customers like came to us and then told us like, okay, whatever you are offering, again, I talked about in the beginning is like around this multi-tenant fleet, but like there are some like really stringent performance customers, those who really don't want to do anything, but they want to use our system so that because Lambda does their job what they want and Kafka is as there. So this layer in between, if it is introducing any can it be more performant? And making performant has cost to it. So we launched a provision mode for Kafka, where you can actually go ultra low latency applications. You can be always ready, ever ready. So we introduced this provision mode where like all these like low latency, low latency use cases can be served for both MSK and SMK.
So when you say provision mode, it's a bit like DynamoDB provision mode or Lambda. I forgot the exact name, but the Lambda has also like a pre-started mode where the system is always on, so it reduces the latency when a new message arrives in. That's the idea.
Yeah. So it's like now you can actually rely on. You don't have to rely on this system where like okay. Like AWS does it, but now you can control your own destiny. Like if you are ultra sensitive, you can go and again. We love abstractions, so we build this abstraction where you can set like one value, and we do everything in like for a fraction of cost that you could do on your own. So it's like something that we launched in like reInvent 2024, and it's already getting a lot of traction. Customers are using it. Go give it a try.
And if you want to know more about it, just check the links in your podcast application or on the website. Everything that we talk about is linked from the notes of this episode. Rajesh Pandey, your principal software development engineer in the Lambda team. Thank you for explaining us how customer can integrate even source to Lambda, how we deliver all these events from these different services to Lambda function. Tiffany, thank you for co-hosting this episode with me. Thank you for having listened to the end, and see you next time, next Friday, next week in all good podcast application. But now go build.